SLS 3D printers are known for producing high-performance parts for applications that require a superior strength. But are these parts compatible with a pressure formers like the Mayku Multiplier's high temperature and a pressure of up to 60 psi? Hello, I'm Agustín from Mayku, and in this third video of our series on 3D printing and thermoforming, we will explore the benefits of using SLS 3D printing to create thermoforming templates. If you missed our video about filaments and resin 3D printing, check the links in the description. We are in this Fab Lab and showroom located at Universidad Francisco de Vitoria in Madrid, where some of the best prototyping and manufacturing technologies are used every day. Let's get started. First, let's take a look at the SLS 3D printing technology. Selective laser sintering, or SLS, is a 3D printing technology that uses a high-powered laser to fuse small particles of plastic powder together. What's interesting is that SLS doesn't require any support structures, as the powder acts as its own support. SLS is part of the powder bed fusion family, which also includes, for example, multi-jet fusion. When it comes to thermoforming templates, both technologies offer the same possibilities and share very similar workflows. Let's talk about the benefits SLS 3D printing offers in thermoforming applications. First, due to the 3D printing process itself, SLS parts are porous. This means that there's no need to add air holes to the templates, or that you can highly reduce the number of them. This is big in thermoforming, as air pockets in your templates can cause the plastic sheets to bubble and deform during the forming process. Second, we have the SLS materials. One of the advantages of SLS 3D printing is that its default material is nylon. This material offers excellent mechanical properties and a high temperature resistance. And yes, it makes it ideal for making thermoforming templates. There's no need to use strange materials or implement a different or more complicated workflow. Next, the templates made with SLS 3D printing have a long lifespan. Thanks to the nylon material properties, SLS templates can be used multiple times. This makes these templates perfect for small batch production. And last, we have part complexity. SLS is really good at creating complex parts due to the laser's resolution. In addition to this, SLS doesn't require any support material, allowing for greater design flexibility. SLS is a pretty straightforward technology, and it complements thermoforming very well. However, there are still a couple of tips that we want to share with you. The first one is about parts orientation. When preparing to print SLS templates, consider the orientation of the parts on the build platform. The powder temperature can slightly change depending on the location of the parts, and that could lead to warping. And second, let's talk about surface finish. One of the only disadvantages of SLS 3D printing is that the resulting parts often have a grainy surface finish. That doesn't affect the thermoforming process, but the formed part will also capture that grainy surface finish. If you want to achieve a smoother surface, media blasting is the best option. Polishing and coating is also an option, of course, but it may affect the part's porosity, which plays a key role during the forming process. At the beginning of the video, I mentioned that the standard material for SLS 3D printing is PA12 or nylon 12. As expected, that's the material that I recommend the most. As you can see, SLS 3D printing is capable of manufacturing very resistant thermoforming templates. Thanks to the dimensional accuracy it can provide, the templates can be used to create end-use parts. On top of that, the strength and temperature resistance means that the template has a very long lifespan. And last, SLS allows for the creation of templates with very complex geometries. If you want to learn more about 3D printing and thermoforming applications, I invite you to watch our other videos and also visit the Learn section on our website. Thank you very much for watching and see you on the next video.